So I'm William. I'm the president and the co-founder of the fStop Foundation. Our mission is to use photography for a positive effect in conservation. And we do that here in Florida. We do it with amazing conservation partners in Yellowstone in South Africa, hopefully soon in Glacier National Park as well. And As well as other partners that we have where they use the content that we generate. So the way we do what we do, a great portion of it in Florida, as well as actually in Yellowstone and in Africa, because the wildlife is so elusive, and we are trying to help the endangered Florida panther, which not only are they very elusive, but there's not that many of them. There's maybe around an estimate of about 200 in the whole state type of thing. And we end up, in order to be able to photograph them, we end up having to use remote cameras. And that is everything from your normal Browning camera that you see, out on the trail where you're hiking, that hunters use, etc., to much more elaborate systems, some very complicated infrared 4K video cameras and stuff like that. So, and now 360 stuff. So we use a large variety of products in the inventory of what we generalize as remote cameras. From that, that's only, that's one step, is to have the permission to get out there in the right areas, with the cameras, having the support for partners like Browning, etc. But then we have to figure out, what do we do with all this content, right? And each one of these cameras has its own SD card, and it's producing an awful lot of content, to the tune of about 22 terabytes of content so far since we started doing this. So getting all of that into one place is kind of step two, and we use Google Drive or Google Workspace for that, where we have a bunch of folders, each one for each camera. And then a very important step comes in, which is using a small army of volunteers that we use to sort through all of that, because the content is great, but it's basically useless unless you actually go through and sort it and then categorize it, right? So you got to get rid of the content that is nothing but weeds blowing in the wind, false triggers as we call them, to actually sorting the ones that are of what we call four legs, two legs, wheels, or wings, right? So anything that is not vegetation moving. So it could be vehicles, it could be people, it could be birds, animals, etc. And then the next step after that is to actually tag it. So again, it's one thing to recognize that there is an animal on the video or on the image, but then somebody with some kind of experience has to come in, or training has to come in and tag that and recognize what the species is, whether it's day or night, etc. So that then the last step is that the content producers, the creative team, can come in and sort through this enormous database of content, of videos and images, and pick what they need to put into the final product, which is a video or a film, to help create that awareness for conservation, right? So it's this long process. Volunteer-wise, we have about 11 or so field techs that are out in the field doing the servicing of the cameras, the uploading of the content. But then we have over 50 volunteers that are sitting there sorting and tagging. A lot of them are students that have service learning hours that they have to comply with at a local university, and we couldn't do it without them, at least not for now. That's basically how we do what we do, and luckily the end result is award-winning films and videos that have been shown in all kinds of different places. So that's sort of a long-winded answer to who are we and what do we do.
No, that's great. I love it. So, and if you had to like distill your mission into like a couple of sentences, what does that look like?
well, the basic mission is use photography to create positive awareness for conservation.
Cool.
And it doesn't matter where we get the pictures from or how we, but you have to end up creating that positive awareness. And we left the word positive in there on purpose because even though we don't shy away from telling the problems that exist, we feel that by having a positive message, you have hope, and people are more likely to tune in. People are more likely to get involved and try to do something rather than just doom and gloom.
Great. Cool. And so do you know offhand how many trail cameras you have out there?
It's people are often asking how I don't know an exact number, but it's kind of hard to have an exact number because it's a moving beast. It's about 160 right now in Florida.
Okay.
140 or so in Yellowstone, and about 80 in Africa. Yellowstone and Africa, we donated the cameras. They're not ours. There's different teams, but about 160 in Florida. And the reason it's a moving target is because every week there could be cameras that are taken out of the field because they're not performing well, that have been flooded, so it's a hard number to pinpoint on any given day.
Yeah. Okay. So you said 160 trail cameras in Florida. You're generating data on the scale of terabytes. And so in the world of data science, right? Like at the top of the funnel, you have all this information. You have this constricted set of a human bottleneck where you're trying to take all of that data and get meaning out of it. What species is this? Is this a panther? Is this panther the same panther as the last one that we saw a couple of months ago? Is this the panther that was maybe, struck by a car last week or something because it's the same area? And this is the sort of like classic application of data science. Can we start at the top of the funnel with all the data and replicate the sorts of decisions that humans were making with the data, but maybe we can do it faster? Maybe we can do it a little bit more accurately, at least at scale. And so that's, I think, why this project works so well, is because it's from my perspective, a largely unexplored application of some of these technologies, but it shares the classic structure of like a data science problem. Tons of information, and then there's like a human constraint. Before we get into the paper, could you explain why it's exciting to you, the prospect of identifying individual panthers? Why is that a neat idea?
Well, it's beyond neat. That would be absolutely amazing. Why? So we won't talk about the whole species, which is puma, right? There's pumas in the whole United States. Let's just talk about the Florida panther. So the Florida panther is a subspecies, and it is categorized as an endangered species under the Endangered Species Act, right? So it's a federal listing, and the reason it's so important is that in order to get the panthers out of the endangered species listing, we need to have 3 distinct populations of panthers in Florida of, I believe it's 240 individuals each. And then one of the populations has to be going out of the state into their historic grounds to find more genetic diversity. So that count is very hard in Florida. As a matter of fact, the last official estimate from Fish and Wildlife Conservation Commission was between 120 and 230 panthers, adults and subadults. And that's a huge range, right? From 120 to 230 is this enormous, range of panthers. And the reason that's the case is because they're very difficult to count. They when you see one walking by, or if you're that lucky, you see the other one, they look identical. There's no stripes, there's no spots. You see them on camera, and it's really difficult. So in terms of a population estimate, and what happens to this endangered species, it's critical to know how many are there, right? And in order to know how many are there, you have to be able to tell them apart. You have to be able to say, that's not the same panther I just counted. Now, a lot of that is geography, right? If I count one on the southwest part of Florida and then I found one in the middle of the state, it's not going to be the same panther. Well, they could travel that far, but it's probably not going to be the same panther. But what about if you're where the greatest population is in southwest Florida? And so it's critical to be able to identify them, individually. And it's been something that's been exceedingly hard, even for, the panther biologists that have been doing this for 30 odd years. So being able to have, your system um, figure out and identify, this is the same panther, this is the same panther, or not, would be a game changer. It allows us to basically, between all of us that have cameras in Florida, sort of have this communal understanding and measurement of which panthers are we looking at. And then, if it's accurate enough and it's deployed enough, then we can actually start counting. Now, there's an additional reason why it becomes, hyper critical and important to have that kind of system working. There's a thing called FLM. Basically, what it is a degenerative disease that is affecting panthers and bobcats in Florida. We know that it has spread outside of Florida. And it's usually lethal, not always. And basically what it does is it attacks the spinal column and it makes the hind legs basically useless. So a panther will be walking and all of a sudden the hind legs will collapse. And at that point, it usually gets back up and walks a little bit more and then collapse, depending how bad it is. But it becomes a point where it can't hunt. It can't, and it's usually lethal. So to be able to identify specific panthers and help the researchers also sort of correlate that with is this the same panther that we saw a month ago that was looking fine, and imagine if we have enough cameras knowing where that panther has been. They have figured out what it is. They know that it's FLM, but they haven't figured out what is causing it. And it's the theory so far, as far as I know, from last time I talked to the biologists, is that it's a combination of probably genetics and environmental or something else that's triggering that genetics. And so that's another reason why a individual identification of a specific panther, particular panther, would just be huge as well. So yeah, really, really groundbreaking, because I don't believe it's ever been done. And obviously we do it with humans, right? We know we can do it with humans with facial recognition software. So it would be a big deal.
Okay. All right. Thanks for all that context. Okay. So identifying an individual panther and being able to take its photo in the wild and say that is the same panther has huge implications for multiple reasons. And is it true in general to say, like, the better you are at doing that, the better you are at protecting them? Like, to identify a panther is to protect it in a sense.
Absolutely. Because so what's the biggest killer of panthers, right? The biggest killer of panthers is not FLM so far as we know, it's vehicles. And being able to identify individual panthers also gives us the ability to see where they're moving, how they're moving. If it has a collar, a GPS collar or a radio collar, that's relatively easy, right? So being able to identify them does directly relate to us being able to protect them better, right? If we know where they're moving, where the pinch points are, and work off of that. For example, Department of Transportation can figure out, hey, we need to put a crossing here. Not that we don't know now because we can see the panther on the camera, but there's still a bit of an unknown. For example, if we see a panther crossing underneath I-75, Alligator Alley, major highway in Florida, right? That cuts the state east and west. If we see a panther through one of the existing wildlife crossings, we can tell it's a panther. We can tell if it's male and female most of the time. But we don't know if that is, for example, a dispersal event, right? Is that a younger male that's coming from the south that's getting pushed away by larger males and it was a one-time crossing? right? It's just crossed once as it's starting to head north to find its own territory, or is it the one we're seeing multiple times and this is its territory? So there's a lot of decisions and a lot of information that can come from understanding where they're moving, how they're moving, and that's helped tremendously by knowing, is it the same panther?
So, as you already know, and as you said before here, you upload your images to a Google Drive. I was able to connect to that drive programmatically and download images so that if this were a data pipeline, that's the sort of terminology we use for like a big sophisticated step-by-step process that gets you from like one point to another. If this was like a working data pipeline, you'd be able to upload and from your trail cameras directly, and we'd be able to like download to either like a cloud solution or some sort of like software that you guys would use on site, which is cool. That's a big step. Now, one of the first issues we run into when we download directly from your drive is your images, although they do have an organization system that's really useful, they aren't necessarily organized by species, sort of. Like we've talked about, you can sort of search for a species and it might show up in the tags and the metadata. Um, but there are places that are sort of like named after certain species. So like a bunch of different stuff will show up. Um, so the first thing I wanted to do is I wanted to download a decent chunk of images. I got around 1,500, and I wanted to see if I could train an algorithm to detect the species. With those 1,500 images, I was able to get up to 77% accuracy. So if you give me, you know, a, 1,000 photos, I can tell you which species is which in 770 of those photos. So I was super pumped about that because that means that um, there, like you said, there are like misfires and there's vehicles and there's people walking through, and you do have volunteers, and that sort of like helps you, connect with people anyway. So there's a sort of like benefit in there. But at scale, you'd want to be able to sort through images really quickly and efficiently, right? And that's one of those things where it's like it's just exciting to be able to take a step like that. So I was happy about that accuracy rate.
Yeah, it's pretty awesome.
I think that the headline so inside of that 77%, there's a bunch of different species. The number one most accurate species, 100% identification, perfect identification with no false negatives, panthers. I can perfectly identify panthers in your
That's
photos.
awesome.
Isn't that great? Isn't
That is
that cool?
awesome. That is
Yeah.
phenomenal.
Okay, so you upload images, I can get to panthers. So what's next? So we want, again, the North Star here is, can we identify individual panthers? One of the problems that we have is pan I'd say there's two big issues that we're dealing with at this rate. The base rate, meaning the probability that if you take 100 photos, how many photos of those are going to be panthers? The base rate of panthers is very, very low. They just don't come out to say hello very often. And so you don't expect to get tons and tons of photos of panthers unless you're really lucky. So you're going to be working with a smaller set of images. The other problem is that, and this is sort of two-pronged here, at least from my understanding, panthers are curious like a cat. And so when they see the trail camera, they might come up and kind of like stare at it sometimes. So you might get a beautiful head-on shot, but there's a lot more shots of a panther walking sideways or away or just sort of like off in the distance, which is true of any animal. So the base rate of panthers low, but the base rate of a panther looking directly into the camera is extraordinarily low. So it's like if you take 1,000 photos, maybe 20 of them is a panther looking into the photo. So the first thing I did was I used it's a technique called ISOMAP, and it basically, the math is complicated here, but I'm able to arrange the photos in a way that picks out moments when the panther's looking directly into the camera. And I can also tell you like when it's walking away and stuff. It's a spatial way of organizing photos where it can say like, okay, its right shoulder is facing you here and its left shoulder is facing you here. And in this section, it's actually looking head on. And then on top of that, we can use another technique called k-means clustering where I can, so I've arranged it spatially. Now I can use clusters to pick out only those photos where it's looking in. So now, and I'm super happy that that works. So now we can go from you've uploaded directly to trail cams all the way down to I can give you photos of panthers looking directly into the camera, which is great. Yeah. So we ended up with, I think 20 or so pictures in just the data set that I had sorted through of panthers that were head on. And then I sat down with you and we said, okay, which panther is which? And we're sort of like zooming in because we need labeled data in order to say how accurate our algorithm is. So we go through and we pick that out. And then I ran it's a library called TensorFlow. It's a convolutional neural network. And what it's for facial recognition. It's a facial recognition algorithm. And the basic gist here is that if you imagine a poster on a wall, like imagine a map on a wall, and you took a photo frame, an empty photo frame, and you moved it around on that map, and you only looked at what you could see in the photo frame, that's what convolutional neural networks do. It's looking at little subsets in every image, and it's trying to identify patterns that it finds in those subsets. So one of the examples that I point out in the paper is that one of the panthers has an ear with like 3 little cuts in it. And we were able to use that to identify like, okay, this is a unique panther that we can see in 3 or so of these photos. So CNN doesn't seek that out. It doesn't know that there should be a thing there. But if there is a thing there, it kind of like exploits that. Like it doesn't know that birds should have beaks, but if it sees a bunch of beaks in photos, it's going to say, okay, well, maybe these are all the same thing. So we were lucky, and I was pretty happy with the results. We were able to correctly identify a unique panther with 66% accuracy. So it's not perfect, but I think I like 66, but what I like more is that one of the panthers in our data set was help me out. It was part of the FWC. It's like a semi-natural habitat that it's living in. The drive that you sent me.
Was it
It,
224 that got hit by a car or
it looks like it's in a cage, but it's like a natural environment and it's wearing
yeah,
like a
so
neck.
yeah, that
Yeah.
was I believe that was FD 224 that I sent you. She got hit by a car twice, rehabilitated, operated on, and then the rehabilitation to be able to release her back into the wild. Because you can fix the leg, but she still has a weak leg and system and everything else. So it goes up to a place called White Oaks, actually, up in Jacksonville.
Oh, yeah.
And yeah, that the reason it looks like a cage is because it's a big cage, big environment for them, and the whole idea is that the vets can continue to care for her, but there's no human interference in her feeding or anything like that. So she doesn't get, she doesn't see that correlation with humans. I mean, she basically doesn't see any people.
Mm.
And, food is entered into the cage without her seeing where it's coming from. And that allows them, plus a lot of other things, but it allows them to release them back into the wild.
Got it.
Which is it's absolutely incredible that they go through all of this. 8 months later, they're released, and she's still out there living. So yeah, so
That's
that was
great.
224. I believe that's 224 that you're referencing.
Okay. That's great. Okay. So for the purposes of the video, there was a panther that they were helping to rehabilitate after a car strike. And it was in a semi-natural environment for a matter of months. And as a knock-on effect of that, we have a bunch of photos of the specific panther, a bunch of different environments and positions and all that kind of stuff. So that one panther had 100% accuracy in my facial recognition. And it had one false negative. It doesn't hit the accuracy rating, but it was basically every time it showed up, it was identified correctly. We identified one other cat as it incorrectly, but every time it showed up, we said correctly, this is that cat. So
Wow.
what that means to me, and that was, I think I only had like 12 photos of it. Okay. So what that means to me is that really, really accurate results are not only possible, but close. And all we need is just a bigger data set, more pictures of more panthers, which is why your mission is so crucial. And this is all
Wow.
just like a self reinforcing cycle. The more pictures we have of these cats, the better the models are going to be, which makes your ability to protect them stronger. I
Wow.
kind of thought that that was
That
interesting. What do you
is
think about
that
that?
is super interesting. Well, I'll put it to you this way. So if if I can see certain areas of 224 in her body, specifically her right hip, I can identify her 100% of the time because she's got a scar, right? If I can see a video with the scar, then I'm sure it's her because she's got a certain way of walking from those injuries. I cannot 100% or even 20%, I think, identify if all you showed me was her face because I don't have those markers. I don't have the ears. I don't have, all those things. So the fact that your system can actually do it based on the face and not something simple like a scar on the hip is amazing. I mean that's pretty cool because I don't, as far as I remember, I don't think 224 has any notches. I mean, I never used those to identify her, but that's pretty freaking incredible.
Yeah, yeah. I was super pumped about that. I also didn't see any like visual scars or anything. Maybe like um yeah, I don't know. I mean, one of the drawbacks of these algorithms is that the network can't just come out and tell us like, hey, here's what makes this cat a cat. It's just all a bunch of math that would be really hard to interpret. But
All right,
yeah,
I'm good with
it's
that.
yeah,
That's incredible. That's awesome. Good
yeah,
job.
great. And so, what does this mean? I think for you guys right now, it means here's a system that, and we'll continue working together, obviously, but as it stands, here's a system that if you take and use it, you can go from uploading photos to a drive to um, categorizing species to picking out the moneymaker photos of panthers all the way down to at least attempting to bucket them into individuals. And the more photos it has, the more data that gets ingested, the more powerful the model becomes. And it becomes this like virtuous circle, like we were talking about. So, okay, so great.
Beyond great. Are you kidding me? That's incredible. I did not know that you actually had a specific panther identified with that kind of accuracy. That is, I mean, that was the North Star, right? Now you've done it with one. You just
Yes.
have to do it with another 200 or so.
Yes, that would be the dream. So this is a confusion matrix. I just wanted to explain this really quick because it's weird if you haven't seen one before. Um, we have what I'm calling species, although obviously these are more like just like big groups of
Right.
animals. Um, these are true labels. So here it means there were 100, support is like sort of the total, if you want to think about it. Um, so there truly were 101 deer out there available for us to categorize. Like in the photos, like I have 101 pictures of deer. Um, the amount that my model predicted as deer that actually were deer is 58. So that's a
Awesome.
50% accuracy rate. Um, the deer, I don't know what it is, but the model kept thinking that other random things are deer.
Mhm.
And so I explain this in the paper. I call them deer misses.
I saw that.
You saw that? Okay,
Yeah.
yeah. I thought that was hilarious. So like
That was really good. You had me laughing.
yeah, I wonder if this looked like the hump of like a, I don't know, like a deer like bending over or something, or this was like a neck. It was just kind of funny to me.
Interesting. Yeah.
But so okay, so this was the worst model. This was a better model here. Okay, so out of the 101, the better model got 90 deer. So that's way better. And then you see here panthers. We had 13 to categorize and we got all 13. So this
Oh,
diagonal line here tells you, you know, out of the 27 big birds that there were to categorize, my model guessed 21 of those correctly. The true label is big bird and the predicted label is big bird. This is the ISO map. As you can see here, so this is spatially categorizing photos. You can see here there's like headshot looking photos over here. There's like right shoulder approaching photos here. And then these look like the panthers sort of like walking away in one direction or another. So this is super cool because it's like just because you have a photo of a panther doesn't mean that you can use it. And then this quadrant is sort of the quadrant that we can use. And we can get at that quadrant with something called k-mean clustering, which is basically just finding groups or clusters within the data. Okay, panther identification. We went through this already.
yeah.
The three little tags in the ear, which I thought was super cool. And I put this in the paper because, when I started this, I wasn't convinced. I was down in Florida when I met you, and I was looking at pictures of panthers, and in the back of my head, I'm like, these guys, like, there's no way they can tell one panther from another, but you can. You very much can. It's totally possible. And as you stare at them enough, you will see them.
You did it. You even did it yourself.
Yes. Yep.
You found those three notches, actually.
Yep. Yep. So this is the one panther, the FWC panther that we had the most support for. So every time it showed up in the data, we found it. We categorized one other panther incorrectly as it, but the headline is every time it showed up, we did find it. Thank you so much. It was great to work with you on this, and I'm excited that we got to a interesting result here.
It's been awesome, Jeremy. Thank you, and hopefully we'll do this more.
All right, sounds good. I will be in
Appreciate it.
touch.
Awesome. Great job.
Thank you. Take care.
Bye.
Bye.